is or where it's coming from. If you guys were outside of the observatory, looking at the observatory, you'd notice 3 green domes, right? The big green dome in the middle is our planetarium show. To the left is our telescope that we turn on every clear night. So yes, that works, and you can look through it every clear night. But the one to the right is our solar telescope. And you'll notice the shutters are open. And if you can see inside, you might see 3 mirrors that are lined at an angle, and they're tracking the sun all day, all the way to sunset. What we're doing is we're tracking the sun, bouncing the light off the mirrors, off 3 other mirrors, sending the light down here. One beam is coming straight down the middle through a filter, so you can see a live image of the sun. And then you see these shafts on either side, lights coming through there, to give you 2 more exhibits. The breakdown of the chemical composition of what the sun is made of on that side. And then over here, so you can see the edges of the sun. You can see some of the eruptions happening on the sun, which is very cool. So to start with, when it comes to the sun, it is a star. Which, we take that for granted knowing that now, but the same thing that's twinkling at us at night is what our sun is. And to understand and make that leap when they did was actually a really, really big deal. To understand that there are different types of stars, and it's over here, the main sequence of stars. You got bigger ones, brighter ones, different temperatures, all sorts of different evolutionary points that they're in. Some are exploding, some are being born, all of that stuff. That's what you have here. But our sun is one of those things that's twinkling at us at night. Which again, remember, our ancestors thought the sun was a smooth surface, untouchable. We come to find out the sun is actually a hot mess, literally. It has tons and tons of magnetic field lines. It's forcing hydrogen into helium with its intense pressure, stripping them of their electrons. It's spinning in its place in the solar system. The sun is rotating and producing all these crazy interactions with the magnetic field lines that are produced from the currents of these electrons floating around in kind of this gaseous plasma and causing all sorts of things to get tangled up. The byproduct of all of these things happening is light and heat and good things for us. But it literally is a hot mess, and would never have thought, when you think about it, or if you could even look at it, that it has eruptions happening on the side, there's constant storms, it's a complete mess of explosions and hydrogen fusion pushing things together that normally shouldn't go together. Just for some perspective, whenever you look at the sun, it is huge. You can fill the sun with 1.3 million Earths. The diameter of the sun, you can fit 108 Earths. So whenever you see a sunspot, we have pictures up on these panels here, either on this side or that side, following the sun. You see those little dark spots? Remember, whenever you see anything show up on something this big, you're talking planet size. So those sunspots are the size of Earth. You see a little spot here? You're talking planet size. When you see an eruption happening on the side of the sun, like we have over here, and as you walk around, these huge plumes flying off, you're talking 10, 20 Earth sizes. So when you see just the edge and you're like, oh, here's a storm, it's a very, very, very big storm. So the sun is amazing. It's constantly trying to kill us. You can be honest and fair about that, constantly. We have a magnetic field that protects us from the solar radiation that's coming. We can learn about that from our solar system because Mars looks like it might have had a protective field, but it has been lost over time because it looks like water might have once flowed on Mars. So we can kind of learn about, wow, our magnetic field is very protected. We're very, very lucky to have one. So things like that are very important. When it comes to our chemical composition of the sun, some people ask, well, what does that mean? What does it matter that we know what stars are made of? Believe it or not, the advancements in chemistry allowed us to figure out the size of the universe. Let me say that again. The advancements in chemistry allowed us to figure out the size of the universe. How? Once we started figuring out what stars were made of, then we could figure out what other stars were, where they were in their process, and we can start piecing together for the first time in history how far away these things are in their equations with brightness and temperature. That hydrogen still works like hydrogen. Helium still fuses in the same way. You can start piecing together, wait, our universe is actually way bigger. Think about this, 100 years ago, the debate was, and it truly was a debate, are there other galaxies? Because we didn't have the telescopes at the time to understand these kind of fuzzy things we were seeing. 100 years ago. Downstairs we have a picture with over 1 million galaxies in it, and we just walk on by it and grab some coffee. But that was the big conversation 100 years ago. Are there other galaxies? Now we're estimating that there are about 1 trillion in the universe. Remember, galaxies are really big things. They have hundreds of billions, tens of billions of stars within them. So that's just incredible in and of itself. That's why that's cool. That's why you see the periodic table here related to astronomy. Because astronomers have an interesting problem. They can't play with the things they're talking about, like chemists can. We have to observe from our planet and make the best observations we can. And we can't actually see what a black hole is and how you mix it, what you can do with it. Can't do any of that. We have to just observe. Look at other black holes. Watch stars explode and die, and also be born. And be like, oh, that's interesting. You can find that out with other stars. So very, very amazing. I'll close with this. This is a live image of the sun, but that's a little bit misleading. Does anybody know why? Anybody know why?
It takes time to get here.
Yes, it takes time to get here. The sun is not actually close. It's 93 million miles away from us. And the speed of light, which is a super fast thing, 186,000 miles per second. Just for some perspective, if you took the Earth and if you could bend light, you'd go around the Earth 7.5 times in 1 second. That's the speed of light. So if you do the math, 93 million miles, that speed, it's about 8 minutes and 11 seconds for the light from the sun just to reach us. Which is another reminder, you're always looking into the past when you're looking up at the night sky, when you're looking up at the sun, when you're looking up at the moon. So if the sun